But now I've just got like a
Okay.
170 Rand Logitech keyboard, and it's worked well.
Yeah, yeah, that's kind of upsetting me because I also had a Logitech keyboard which was like 300 and it lasted me 5 years, and I saved up money for a mechanical keyboard now which was like 1,000 rand.
Hmm.
So like the typing experience is really nice, but now I did compare 6 years, and I'm hoping this keyboard lasts long now.
Yeah.
This is kind of make me worried.
No, it's fine. Um, yeah, I think the main thing is that you can type on it, right?
Yeah. Um,
There are some cool keyboards like the Kinesis Advantage 360. I'll drop a link in the chat.
I
Uh,
have a
yeah.
Keychron. Keychron kind of blew up now.
Okay. Yeah, the Kinesis 360 is like a split keyboard. It's pretty cool.
Oh, split keyboard.
Yeah.
Oh, I see, I see, I see. See, have you ever seen a core keyboard or core something? It's basically a 3D keyboard.
No, I haven't.
So, but it's called the core type. It's called something called. So basically, it's like a button
Hmm.
that so like a button on your keyboard. Now
Yeah.
this button can move left and right, like left, right, up, down. So each
Okay.
single button can. So obviously now it has like it has more. So a single button can have more characters.
Hmm. Yeah,
Yeah,
that's
something
that's
like
very
that.
interesting. Keyboards are interesting. Keyboard layouts are also interesting. There's different keyboard layouts for minimizing finger travel and everything. But with all of
Yeah,
these things, it comes down to muscle memory. So if you're going to switch, it'll
yeah,
take a bit of time.
yeah.
All right. So let's have a look at any questions about the assignment or any other general questions. Um, Today we're going to cover interfaces and abstract classes, which are necessary to finish assignment 3. After this, you'll have one more assignment and two more tutorials. So there'll be a tutorial coming out on Wednesday. We'll see if we get
Okay.
another tutorial and then a
So it's
test.
the last assignment coming.
Say again?
Sorry for cutting you off. Is this Friday our last assignment coming?
Yes, this Friday we'll release assignment 4, and that's the last assignment.
I will say so. Out of all the assignments we did this year, I feel like yours were much bigger than the other lecturers. But
Yeah,
like the thing I like about yours is that it carries with the lectures or like that we do.
yeah. Yeah, so I did try to design them that they A use what you learn in the lectures, and B that they kind of are more easy to more difficult. So the beginning of the
Yeah,
assignment should be easier and the end of the assignment should be more difficult.
yeah.
Yeah. If
Yeah, so it was quite at first like when we got the first assignment, I was a bit overwhelmed, but then I realized that because I thought it would be overwhelming for
Yeah.
to get this assignment and carry on with new lectures, but I realized the new lectures like assisted in the assignment.
Yeah.
So yeah. And
Yeah.
as for assignment 3, I didn't do it as yet because they said that we'll cover more of it on Monday. So what I did was I reviewed all that we did,
Yeah.
the polymorphism and inheritance and super. So I have a much better understanding. So in a very short explanation, inheritance is basically just the extend feature,
Mm-hmm.
and super is basically just calling a parent class. So like the parent and the child.
Yeah.
And so basically if you put super in the child class, it can just take some of the objects or constructors from the parent class.
Yeah.
So I understand that. And polymorphism, I don't know how to explain it. Basically, if you have something, I saw a YouTube video. Basically, if you have the exact same thing in each class, and if you run it, it will display the last one. Okay, I'm pretty sure I'm explaining very badly,
The most
but like
recent one, yeah.
yeah, the most recent one. Yeah,
Yeah. No, it sounds like you've got everything under your belt and you've got
yeah,
it correct. Yeah, so today we're just going to talk about interfaces, which are, yeah, they're pretty interesting. And then abstract classes, which are just, so everything is just a slight addition to the previous work that we've done. We're kind of just
Yes,
slowly
sir.
adding on top of it. All right, let me just double check if we have any further questions. All right, so we'll get started. What time is it?
So
Yes.
sorry. So the tutorial, is
Yeah.
it being opened on Wednesday or will it be due on Wednesday?
So last week's tutorial,
Yeah.
tutorial 1 for term 4, is due on Wednesday, and the new tutorial will open up on Wednesday.
Oh, okay. Thank
Remember, you have 2 attempts for the tutorial, and we'll record the highest mark, and then you have the whole week to try those 2 attempts.
Okay.
Yeah.
Thank you.
Yeah, you're welcome. The idea being is that you can try it once, see what you don't know, brush up on your work, and then try it a second time.
Okay.
All right. So, without any further delays, unless someone has a question, I think we're okay. We'll start with interfaces and abstract classes. Interfaces deals with polymorphism. Abstract classes deals more with inheritance, but we'll be going through both of them. So for this, we expect you to know the basics of polymorphism, just like Akib briefed us in the beginning of the lecture, the basics of inheritance, and then we're going to look at these new extensions or these new ideas. So just briefly, with inheritance, just like Akib said, classes may inherit from other classes using, and in Java, this keyword is extends. Extends, right? So that's how you say we are inheriting from something. The subclasses extend a superclass, so they go from like a more general class or a general idea to a more specialized version. Subclasses may override methods in the superclass, and then part of encapsulation is that subclasses may not access any private variables or method in the superclass. And what we had were 3 different access modifiers. That's another C. Access modifiers, which was public, private, and protected. And protected, so public and private we already knew, and then we learned that protected means that the current class and any subclasses can access something that is protected, but nothing outside of that. Right. Then with polymorphism, we have that subclasses can be treated as any of their ancestors. If a subclass overrides a method, the newest version of the method will be called. This is called dynamic or late binding. Okay, so this is the technical term, and then this is the definition. Okay, or at least the usage in polymorphism. So, an interface, if you can think of like a really complicated machine, something like a nuclear power station, you have like the internal generator with all the nuclear stuff going on there. You have some like very special control rods and fans for turbines. And all of this is like a very complicated system, right? With an, I don't know, we'll put like cooling towers or something. You have a very complicated system, but what we do is we have a control room where there's like a control panel and there's just one button or a bunch of controls, right? Computers are the same. We have like very complicated inner workings to our programs and everything. But then we have a keyboard and a mouse. And what we do is we use like this well understood interface to interact with a complicated system. So in much the same way, a interface is a set of methods that we can use to interact with an object. Okay, so a class interface is all of the public methods and public named constants or variables, right? Because that is what you have access to. So if you have some sort of object, you can only access certain methods, which are like the buttons, and look at certain values, which are public, and those are like the dials, right? So you have this kind of interface over here, and then you can interact with the interface. But internally, due to encapsulation, we're controlling the internal state of the object. Okay, so this is what I want you to get in your heads, is that an interface is like something we can interact with. Now today, we're going to look at an interface. So I'm going to differentiate when I speak about an interface with a small letter like this. When I speak of an interface, we're talking about the class interface. So public methods, named constants, and variables that you can interact with. When I talk about a capital I interface, right, I'm talking about the specific Java construct. Right, so we're going to try and keep these two separate, or at least the ideas, because the ideas are slightly different between the two. Right, just give me 1 second. All right, so we can quickly look at a class interface by just looking at the public methods and their parameters and the constants and attributes. So if we had something like a parent class, and we want multiple classes to present the same interface, we have a parent class with something like my method, and because of polymorphism, we might store like a bunch of, so if we had one like parent class, and then we had a bunch of child classes, right? With polymorphism, we might want to store them all as the same thing. And this is one way that we can control the class interface. Okay, when we use inheritance, we know that all of the child classes or the subclasses inherit the public methods. So they inherit the class interface of the parent. So this is useful in the case of things like user accounts, so like a Canva system where any user, let's get rid of this. The idea being is that any user can do a set of actions such as login, view a page, and then maybe like log out, right? So these are standard behaviors that any user may be able to do. Then you have the idea of a student and the idea of like a lecturer, and a student might be able to like take quizzes, right? So take a quiz, and a lecturer will be able to, when they're a decent lecturer, add resources. Okay, perhaps with some delay. So if we want, we can say that this interface is the same for all users because they all inherit from a student and a lecturer and so on. But sometimes our systems don't work this way. Sometimes they're a lot more complicated, and we might have unrelated classes that need to have a standard communication or a standard method for working with each other. So a standard shared interface. And this is where Java interfaces come in. So with Java interfaces, it is a program component that contains the headings for a number of public methods. Okay, so a Java interface literally specifies a set of methods that you have to, that something will have. So it's only methods. It doesn't, so a couple of rules. It is only methods. all those methods are public, and the implementation is up to the object or class making use of the interface. Okay, so a Java interface is a way for us to define class interfaces for specific use cases. So sometimes the collections asks that you implement certain interfaces, or for like unrelated classes to be able to communicate with each other. So having something, you can essentially set a standard behavior is a good idea to think of it. Standard behavior, or API, application programming interface, is something you could do, and that an example of that would be like the toString method, right? So toString, and something that uses the toString method or looks for a toString method is system.out.println. Okay, so system.out.println might not even be overloaded for everything, every possible argument you can give it. All that system.out.println does, let me just get rid of this, println just takes anything that's between the brackets and says, okay, anything that's in here has to have some implementation of toString. And if there isn't an implementation of it, the default is to just print the memory address. So actually, behind the scenes, println, when you're calling it, is making sure that every item you have in here, so strings are easy, but like a number, right? It gets a toString conversion and then gets printed out into whatever you're printing it into, right? So that's the whole idea of interfaces, or Java interfaces with a capital I. They are like shared groups of methods between classes that aren't related, that aren't inheriting from each other or share a common ancestor. Okay, so you can think of it as a recipe for a class interface. And the syntax is quite simple. Instead of saying, so usually you would say here class. So in this file would be my interface.java, right? That would be the file. Usually you would say public class, my class, or whatever. In this case, you use the keyword interface, and then you have a list of method signatures. And if you recall, a method signature is the type, the method name over here, the type, meaning the return type, and the parameters list, right? So that's the method signature. And that's all an interface is. It's a file. Well, if you're a good programmer or a nice programmer, you'll put a bunch of comments in there documenting what the interface is supposed to do. You will describe the methods and what everything needs to do. But in essence, you're just defining a set of methods with their parameters and the return types. That's it. That's a Java interface. So I believe in your assignment, you're asked to create the dockable interface. So there's a dockable interface that has two methods, a can dock, right, and a dock. And dock method takes some sort of set of parameters. So you can see how you would be able to write an interface called dockable. Right.
It's like interface, it's like creating a normal class just with interface in front of it.
Yes, but an interface doesn't have any attributes.
Class interface, you're saying public interface.
Yeah.
And then yeah.
But notice that the method is ended with a semicolon. You don't actually add the code for the method. Does that make sense?
So there's no body.
There's no body. What you're saying is when the Java compiler finds programs or classes that implement this interface, then it knows it has these methods available. It's up to the class to actually put the body of the method in there.
Okay.
Yeah. And this is the simplicity of interfaces. It's just a recipe. It's telling them this is what you can expect. So we've already said implement, so this is a good point. If you want to then include this interface or say that your class uses this interface, then you use the implements keyword. Okay, so with inheritance, we will say class A extends B, right? And we can only have one class it inherits from. However, with interfaces, you can add a comma and as many interfaces as you like. So we'll say my class implements my interface, the comparable interface, the toString or whatever, the sortable or whatever, right? So you can have as many interfaces as you need, with the rule being that you have to implement all of the methods described in those interfaces. Okay. So when you implement an interface, capital I, right? A Java interface, as in this code, you must implement an override. So you're overriding all of the methods in the interface. Does that make sense to anyone? Everyone? Anyone as well. If it makes sense to anyone, then we're good.
Makes sense.
Also do an example also at the end.
Yeah, I'll do an example or a demo.
Okay, sir.
Okay. So interfaces, a recipe of methods with a return type, the method name, and the parameter list. When you want to include or you implement the interface, you say your class name implements an interface. And then for each method in the interface, you have to override it in your class with the method body. And you must do it for all methods in the interface. Also, if you use an interface, it is not excluding the fact that you can still inherit. So you can have a class A that extends B and implements X, Y, and Z. Okay, so this is allowed in Java. And in fact, this is how we start to compose really complicated classes. So a class that implements an interface, and this is in terms of polymorphism, a class that implements an interface can be treated as a type. So interfaces are also types. Okay, and this makes sense because previously anything that has ended up in this first header of the class, anything that has gone here has meant a type, right?
Sir?
Yes?
So is that implement basically like extend, like inheritance?
It's basically like extend, but it's only for the interfaces. You can't add a class here.
Okay, I see,
Yeah.
I see.
The rule is you may extend only once. So you may extend only from one class. However, you may implement as many as you want. And these are interfaces. And this is a class. Does that make sense? So you can extend 0 to 1 classes. You can implement as many interfaces as you want, 0 to however many. Okay. So,
Sorry, sir.
yes?
Can you explain it again? I think I'm a bit lost at the amount of classes you can implement in the interfaces. You can only implement one class.
So, yeah, so a class, right, is not an interface. Do you agree?
Yes, a class is not an interface.
A class is not an interface. You can extend or inherit from a class. You cannot do it from an interface. You cannot extend, well, okay, we're going to talk about it a bit later, but you can extend one class with another one. And then a
But you can't
class
extend- okay,
can
I
implement.
understand.
Yeah?
So you can't extend the interface to another interface.
You can extend an interface to another interface. You can't extend a class into an interface because they're not the same thing.
Oh,
Yeah.
okay.
So you can, but that's later on. Don't worry about it for now. Well, we might reach it just now, but I want you to understand the typing first. That we have the interface of a greeter, which has the say hello method, and then a person can implement the greeter interface. And then we implement that method. So we can have a person that's a greeter, and then we can have a robot class that also implements a greeter, right? And then we can store them all as greeter objects. So you can have a person in there and you can have a robot in there, even though a person and a robot are not related, because this is the type that we are polymorphing them into. Is everyone with me? Let me just check the comments.
So,
Okay, so this is another aspect of polymorphism that interfaces let us do. So you can have like wildly differing things as long as they all implement the same interface. You know you have access to those methods. And so you can kind of standardize a method or whatever. Okay, so if you have a store, you can say use a greeter. So the person class implements the greeter interface, and so you can have a store that says, okay, let's use a greeter. If this greeter is a person, that's fine because they say hello. If this greeter is like a video robot, that's fine as long as they implement the interface. It's important to know.
See your shared screen.
Hello? Did you ask a question?
See your shared screen.
Hello?
Hello, sir.
Yeah. Did you say something?
I can't see your shared screen.
Oh, it's on the YouTube channel. Let me share it with you. I'll post the link in the chat.
Okay.
Just check the Google Meeting chat. Okay.
Thank you.
So the whole idea being is that you can kind of have like unrelated classes that might work very differently, but they share the same interface. It also means that even if a person has a method where they can breathe, right? If that is not in the greeter interface, it's not accessible when you use it as a greeter. Does that make sense? Because the greeter type can only say hello. So when we do polymorphism, we restrict, or I guess we put like a we put a filter on top of the objects so that the only things that are accessible are the things that are a part of that type. Does that make sense to everyone? So it's kind of like if we have a person class, they might have multiple methods and attributes, but let's say only the square method is part of the greeter. When we then use polymorphism, we'll have like a greeter template where there's only a square pole. Okay. So we can, when we say this is a greeter, we can only access the method that the greeter lets us access. That's how polymorphism works. Is everyone okay with that?
Yes, sir.
Okay.
Yes, sir.
All right, cool. So now we can get to the point that someone made earlier. Well, I guess we can, yeah. We can just quickly recap everything. So a class interface is the public methods and constants that can be used to interact with the object. A Java interface with a capital I is a piece of a program describing a set of public methods to be implemented. If a class implements an interface, it has to override and include all the methods in the interface. And a Java interface can be treated as a type, such as for a parameter to a method, or elements in an array, or whatever. This is because all of the objects of that type share the same public method. Also, treated as a type is part of polymorphism. My handwriting is terrible today. So, previously someone was talking about the difference between extending a class and extending an interface. You can extend interfaces. So an interface can be extended into another interface. A class can be extended into another class. An interface can't be extended into a class, and a class cannot be extended into an interface. Okay, so just be clear that it's an interface extends into an interface, class extends into a class. Okay.
They're basically saying a class extends into a class and an interface implements into an interface. Or what?
No, it can also extend.
So you can use the extend feature, the inheritance feature.
Yes, but you can only go from interface to an interface, so creating a new interface.
So what's any difference with implement? It's just the same as extend then. For the interface.
No, so implement says that this class uses all the methods in that interface.
Okay.
So a class, let me make this a bit clearer. So with extend, we can do an interface extending an interface, and an interface and a class extending a class. A class extending a class. When we implement, we can only have a class implementing an interface. Does that make sense? An interface can't implement an interface because then it has to flesh out all the methods, right?
I think I said the same, sir.
Yeah.
So you can't say the class extends the interface, it only implements the interface.
Exactly, yes.
Okay, I think I see it now, sir.
And an interface can't implement an interface. It can only extend. Did you have anything else to add?
No, sir.
Okay. Does someone else have a question?
Yes. For implementation, so the interface can implement the class as well.
No.
No. Okay.
No. So you cannot have an interface implementing a class. Not allowed. Yeah. So it's only a class implements an interface. That's the only relationship that's allowed. Does that make sense?
Yes, sir.
Okay, excellent. So with that in mind, we can extend interfaces from a more general interface into a more specific interface. Okay, in the exact same way we're thinking about inheritance with classes, we'll extend from a more general interface to a more specific interface. So maybe in general, we have an idea of a network interface. You can imagine a network, right? Something like the internet or the mobile phone network, or even in the future, like a shared brain network, the matrix, like all these things are networks. So we have a general interface called a network, and the methods we set out in the network interface is a connect method, which returns a Boolean that says whether or not the connection was successful. So now, every class that uses the network interface must define how that object connects and returns a Boolean. So that's the basic idea. But like we said, there's many different networks. So we can specialize the network interface to a internet network, right? And in the internet network, we have like the internet protocol commands and a bunch of extra stuff. So we can connect to the internet, and then we can do something like get an HTTP header or an HTTP file, or make a status request, or whatever. These are all things that are related to the internet and not networks in general. Okay, so we can have objects that are able to connect to like a general network, or objects that can specifically connect to the internet. So if you had a phone, you can imagine how a phone has a internet network connection, but it also has a mobile network interface, right? You can think of like a laptop and a desktop computer. They might have a Wi-Fi interface as well as an Ethernet, so a cable interface to connect to a network. Right, so this is the idea behind extending interfaces and using inheritance for interfaces. Does that make sense to everyone?
Yes, sir.
Okay, cool. So, with this idea, we're gonna kind of cap that off. If you have any questions about interfaces, ask me now or after the lecture, but we're going to move on and talk about something called abstract classes. So, with the network idea earlier, we had the idea of a network, which is very vague, right? And then we might have the idea of something like a computer, which is very vague. And we have different types of computers that we actually interact with and that we actually use. So something like desktops, laptops, servers, and cell phones. So we may have some base class called a computer, but we never actually want to instantiate a computer object because it's not one of the possible types of computer. Okay, so to do this, we use something called, we want to have the shared type idea of a computer, but we're never actually creating a general vague computer object. We're only ever working with a laptop or a cell phone or a desktop. So with this, if we only want like that ancestral kind of umbrella type, we use something called an abstract class. So an abstract class is exactly like a blueprint, and it can only be used as the base class for other classes. We can't actually create objects, like we can't use the new keyword. They don't have constructors, or at least they don't create actual objects. But we can create an abstract class and then use that as like the blueprint or the foundation for creating all the different types of classes we want from it. And then we know they have the same kind of attributes, they have the same core methods and core design decisions. Okay. So to do this, we just take a class. So if this is the file, there we go. This is the file computer.java. Right, in computer.java, instead of saying public class computer, we say public abstract class computer. So this is another keyword. Okay. So with public abstract class computer, we are looking at an abstract class. It's literally that simple. And here we can either define a method. So we have two options. We can either define the method as in an abstract, an interface where we just give the method with the return type and the parameter list. In this case, we call these abstract methods. Or we can actually implement something and then have other classes down the line override it. In both cases, if we want to implement these in subclasses, we need to use the override keyword, or we need to override those methods. All right. So we actually have 20 minutes left. I'm not sure if I should go on. Let me just double check. Okay. So with an abstract class, I think we'll finish these lectures. It should be fine. But we'll make sure to review them on Wednesday as well. With an abstract class, you can define the attributes, the core attributes, kind of the core methods, and so on. And then when you have methods that are left up to the subclasses to implement, you call them abstract and you don't fill them in. If you are, you can also give that method a body already, but subclasses may also override those methods, right? They still have the option. So you can think of abstract classes just creating a blueprint, and when you have like the methods listed but you're not implementing them immediately, you call those abstract methods. So they need to be implemented in the derived class, much like an interface. We can also specify that an abstract class implements an interface. So if we have some sort of abstract class, we can say that the computer must implement the internet interface. This means that all classes that derive from the computer can inherit either from the class computer or from the or be treated as the internet interface. Okay, so you can see how the base types for any future computers are now already set as both computer or an internet interface object. Okay, so what we're saying here is that all computers can connect to the internet. Is everyone with me? Are there any questions so far?
So is abstract classes mainly for interfaces?
So abstract classes are for blueprinting your classes, and if you want to group them together under an even more general type. You know you're never going to use it, but or directly instantiate it, but you want to make sure that all the subclasses, you have that option of like a shared ancestor. Like future classes, it doesn't stop derived classes from implementing their own extra interfaces. It just means that they all must implement this interface. Does that make sense?
I get that, sir. Yeah.
Okay.
Yes, sir.
All right. So if it makes sense, let's just have a look at everything that we learned and kind of just try to put some of the puzzle pieces together. So we have this idea of encapsulation. encapsulation is controlling the data. So things that are accessible outside of the object, things that are only accessible inside of the object, and then public methods and behaviors that we can use to interact with the object. With that, we have the idea of static class methods. Don't worry, we'll do a review session. I think it's next week. Let me just double check. Yeah, we'll do a review week. Maybe not next week, but the week after, I think. Anyways, and then so static methods are related to a class, right? And not just the object. So if this is the class and this is like a object, right? Static methods and attributes exist in the shared space of the class. Then we have inheritance, where a class can be extended into a more specialized class. We have method overloading and overriding. Overloading being where we take a method with a name and then we change the type and number of parameters. Overriding being if we had a method in the parent, we re-implement it in the child or the subclass. We had this idea of polymorphism, where a class, so a certain class can be treated as any of its ancestors, right? Or any of the interfaces it implements, or any of the interfaces of its parents. Okay, so polymorphism means we can at will kind of treat objects as different types, and each time we treat them as a different type, we restrict the list of methods they are able to use. Then with interfaces, it's a way for us to have a recipe of methods with a return type and a list of parameters. Then with abstract classes, this is like the blueprint class for other more concrete classes, right? So classes that are actually implemented. All right. So what I'm trying to get across to you is that all of these things can be mixed and matched and used sort of interchangeably. The fact that you can have a class that extends, right? You have a class that extends another class that implements, multiple different interfaces. You might have a method, and that method can be overridden. You can have that method overloaded. So these are all just tools. It might sound very complicated, but all of these are tools to help us write really complex systems in a manageable and common sense or logical way. Okay, so just knowing what they are and what they do is considered the knowledge. Wisdom is knowing when to use them or when they will apply to make your life a bit easier. Later on, either next week or the week after, we'll talk about design patterns in Java. That won't be examinable, but it's more useful if you're looking at doing internships or working in industry. But for now, don't worry about them too much. What I want you to try and do is to acquire an intuition, a wisdom about when to use and how to use these systems. So how to use them, right? Very important. We will make sure when we're testing with the assignments and everything, we are testing that you know what they are and how they work. However, what's even more important is that you build up an idea of when to use them. Okay. So with that, we'll do a recap lecture on Wednesday. I'll be releasing the my solutions for the assignments on Wednesday as well, because I don't think we had any extensions for assignment 2. And then we'll go on to something called generics in Java. That's playing with the type system. and then we'll do a recap, do a couple of like patterns and so on. And then we have maybe time for a special topic. So if you had an idea for a special topic, I know someone suggested game development. If you had something else you wanted to see, send me an email or let me know so that I can prepare something. All right. To do, just have a look at, I'll upload the equivalent interface for 2 objects. And then I'll upload the person and student and undergraduate student for you to look at. Implement a computer subclass of your choice. Add some methods. This is more just like exploring how interfaces work and how to use them at the abstract computer class. Abstract. Okay. And then finally, these are some software design patterns and common interfaces for Java that you might want to look into and read about. But with that, that's the end of today's lecture content. So I'll open up the floor to any questions. We can maybe do a demo. Otherwise, tomorrow, Wednesday, not tomorrow, I'll start off with a recap. We'll do some demos to look at what the code's doing and try to compile some programs. And then we'll go on with a bit more of the generics, Java generic stuff. All right. So any questions regarding the material?
Nothing my side, sir.
Okay. Well, it seems like everyone's on board, which is very good to hear. And if you're confused, that's fine too. But then I encourage you to ask questions to help fix the confusion. Okay, if there are no further questions, you're more than welcome to enjoy the rest of your afternoon, drink some water, get some sleep. Remember, you have a tutorial that will close tomorrow, Wednesday. Not tomorrow, Wednesday, just before 12 noon, and then a new tutorial will open 12 noon tomorrow. All right. Otherwise, enjoy the rest of your afternoon, enjoy your evening, and enjoy some Java, hopefully. If you don't enjoy Java, blame the compiler and blame the language designers.
Enjoy your day.
Thank you, Akib.
Thank you, sir. Enjoy your day.
Thank you. You too.